In this video, I'm going to focus on probably the single most important topic in this entire course, and that is interpreting word problems. Now again, this is, as with most of my videos and problem sets, this is geared towards preparing you for the midterm and final exam, since they're going to be primarily made up of word problems. There might be one or two problems that are not word problems, but the majority of the exams will be word problems. In one of my videos from last week, I discussed a general strategy for solving word problems. So I want to talk about that in this video, and I'm going to go through these 7 problems that I have on this worksheet. I'm going to go through solutions to those problems. The first 3 will be on this video, and I'll save the other 4 for my next video. You should watch them back to back. I just don't want to make any one video, too long, to have to watch straight through. Now, for these 7 word problems, we're not going to solve them. I'm going to focus only on the setup, and that's really the important thing here. To solve a word problem, you need to solve an equation, but the problem is you're not given an equation. You have to create the equation yourself and then solve that equation. Now, usually, the setup is the hardest part of a word problem. Once you have the equation, everything that you have to do is pretty straightforward. You just follow these steps to solve using algebra. It's the initial setup. And I talked, and like I just mentioned, I talked about a general approach to solving word problems in a video last week. And that was the 4-step process where doing the math it doesn't happen until step 3. So step 1, you read the problem. You want to understand the problem. You may have to read it 2 or 3 times. You want to determine what information you have, what's missing, and most importantly, what is the exact question you're trying to solve. And then step 2 is develop a plan, your plan of attack for the problem, so to speak. And once you're clear on what you have to do, how you're going to do it, then step 3 is to do the math. And then finally, step 4 is to just reflect for a moment on your answer, not to check if it's correct or not, but to check, does it make sense? For example, number 1 is talking about the distance from New York to LA. Now, if you solve the problem and you get negative 600 miles, well, upon reflection, you say, okay, that's definitely wrong. It is impossible for the distance to be negative 600 miles because negative 600 miles doesn't exist. There's no such thing as negative miles. So as we go through these problems, I really want to put the emphasis on the interpretation and the setup. Now, in the process of setting up a word problem, and I talked about this at length in my video from last chapter, you are translating between 2 languages. You're given a problem written in the English language. And you have to translate that to a statement in the language of mathematics. And this being an algebra class, if you're using algebra to solve a problem. So the definition of the word algebra. Algebra means to use a symbol to represent an unknown number. Now the symbols we use are generally going to be letters, and the standard letter to use is X. So we'll use X as a symbol to represent an unknown number. Okay, so let's look at number 1. On a road trip from New York to LA, Joe stopped in St. Louis, which is 924 miles from New York. If St. Louis is 0.33 of the trip, or 33% of the trip to Los Angeles, how far is it from New York to Los Angeles? Now, generally speaking, and this is not true 100% of the time, but 98 or 99% of the time, the question that you're trying to answer is contained in the last sentence or the last statement. So if you look at the end of the problem, how far is it from New York to Los Angeles? That is what is unknown. That is what we're looking for. Now, if you're going to use algebra to solve a word problem, meaning setting up an equation to solve, you're going to be using variables. And it's important. I can't stress this enough. It is important that your very first step, the first thing you write, is to define your variable. I am going to use the symbol x, and this is what x stands for. And you're going to write it out in words. And when I'm grading your exams, I'm grading you on this. This is required. This is absolutely necessary in giving me a full solution to the problem. If you're going to be using the symbol x in an equation, you have to first tell me, what does x stand for? What does x represent? And in this case, x equals the distance from New York to Los Angeles. That is the unknown number, and we're using the symbol x, so we don't have to keep writing distance from New York to LA every time we need to reference it. So x now stands for the distance from New York to LA. Now, let's see if we could translate this problem from English to mathematical symbols. I talked about math, the definition of math, the definition of mathematics in general, not just this class. Algebra is a part of, but a small part of the general subject of math. Math is the science of patterns. The science of patterns. I don't mean patterns in numbers. I mean patterns in problem-solving techniques. And so I don't want you, even just on this one worksheet, but in general for the whole course, I don't want you to look at each problem as being its own independent, singular, problem to solve. I want to look at the relationships between problems and the trends, the things we're doing over and over. And since we're translating from English to mathematical symbols, identifying key words is very important. So when I look at this sentence right here, St. Louis is 0.33 of the trip to Los Angeles. To me, that sounds like a mathematical equation, because when you see the word is followed by a number, that translates to an equal sign. Is means equals. And when you see the word of, O-F, of, followed by a number, that means multiplication. And so in this case, I see the word of here. It's not literally a number, but it's of, the word of followed by the trip to Los Angeles. Well, that's a number. That distance is what we're looking for. We just don't know what that number is yet. Okay, so let's look at this. So what I like to do is pull the important information from the problem and restate it in as few words as possible. So we could say St. Louis is 0.33 of the trip to LA. All right, so now everything here could be translated into a number, a variable, or a mathematical operation. So the trip to St. Louis. Well, we know how far that is. That's given in the problem. That's the 924. The trip to St. Louis is equals 0.33. Well, that's already a number. We don't need to translate that. Of means multiply. And the trip to LA, the full trip from New York to LA, well, that's what our variable is representing. And so that the full trip to LA, the unknown, that is x. Let me actually write it in red for now. So we see the trip to St. Louis, 924, is equals 0.33, well, that's the number, 0.33, of multiplication, the trip to LA, that's our variable x. So in this case, our mathematical equation is 924 equals 0.33x. Okay, so what we've done is we've taken a word problem written in English and we've translated it to another language, the language of mathematics. And this is called mathematical modeling. A model is an equation. So you're using an equation as a model for some real world situation. Now, another way of thinking that may help, whenever possible, it's not always possible, but whenever possible, is drawing a picture. So, you could draw, actually you should draw as simple a diagram as possible. So we have New York, we have St. Louis, and we have LA. And we're given from New York to St. Louis, let me not use an arrow, New York to St. Louis, that is 924. And New York to LA, that is unknown. And so you don't have to draw it out like this. It's just another way of thinking. I think about these problems as a language problem, translating from one language to another, translating from English to math. And this is a fundamentally important skill in this class. I mean, this is probably the most important skill necessary to pass this class. So this creating your own equation, this is something that should be confusing or difficult in the beginning. And this is not something you learn in one day or 1 week or one section out of the book. This is a skill we have to develop over the course of the semester, over the next couple of months, until you eventually take your midterm exam. Okay, so let's look at number 2. The area of Mark's backyard is about 5 times the area of John's backyard. The area of Mark's backyard is 4,000 square feet. What is the area of John's backyard? All right, again, starting at the end of the problem, here's the question. The unknown here is the area of John's backyard. Okay, so I'm going to define our variable. We're going to let x represent the unknown. Again, this is algebra, using a symbol, namely x, to represent an unknown value. Let's just state it simply. I'll just say John's area. We all know we're talking about his backyard. And now we have to set up the problem. So in this sentence, the area of Mark's backyard is about 5 times the area of John's backyard. Okay, very similar to the last problem. Again, patterns. The same thing that happens in many, many different problems. Here's the word is. There's our equal sign. Here's the word of. That's multiplication. It's not always going to be is and of in every single problem, but in this case, it's a common theme so far. So we could, again, I like simplifying the problem, so let's just restate it. We could say Mark's area is 5 times John's area. So now let's translate this into a mathematical equation. Mark's area, this we know. It's given in the problem as 4,000 square feet. So we know Mark's area is 4,000. Again, we have the word is. That's our equal sign. 5 times, so multiplied by 5 times John's area. And the area of John's backyard, that's what's unknown. So we're using x for that. Okay, so the area of Mark's backyard, 4,000, is equals 5 times the area of John's backyard, which is x. So our mathematical equation here is 4,000 equals 5x. And that, again, we're going to stop with the initial setup. So again, We took a problem given in English and converted it, translated it to the language of mathematics. 4,000 equals 5x, where x represents the area of John's backyard. Okay, so number 3. The height of the tallest building in Anne's hometown is 608 feet, which is about 258 feet taller than twice the height of the tallest building in Laurie's hometown. What is the height of the tallest building in Laurie's hometown? Okay, so again, the end of the problem, the last sentence, that's presenting us with the question. What is the height of the tallest building in Laurie's hometown? We know it's a number, we just don't know what that number is, so we're giving it the symbol x. So I'll call it, let's say x represents the height of Laurie's tallest building. I mean, it's not Laurie's building, it's in her hometown, but you don't have to use so many words. Okay, so now that we know what we're looking for, we've given a symbol to what we're looking for, the height of the tallest building in Laurie's hometown. Now we can talk about translating the problem. The height of the tallest building in Anne's hometown is, keyword is, 608 feet, which is, again, so now we have to figure out which one of those two occurrences of the word is our equal sign. About 258 feet taller than twice the height of the tallest building in Laurie's hometown. So what's underlined in green, that is going to be our equation. So the height of the tallest building in Anne's hometown is 608 feet. All right, that's a statement. So that is telling us a specific piece of information. Anne's building is 608 feet. And that is 258 feet taller than twice the height of the tallest building in Laurie's hometown. So to simplify that, we could say Anne's height is 608 taller than twice Laurie's height. And if you want, maybe pause the video now just to reread the problem and just to get comfortable with the fact that what I've just written in blue states in less words, more succinctly, more directly, the information given in the problem. So now we can convert this, translate this to mathematical symbols. Anne's height, or the height of the tallest building in Anne's hometown. That's given. That's a number. We know that number. We don't need a variable here. That's 608 feet. Oops, sorry. That was a mistake. I used the wrong number from the problem. Is 258 feet tall. I think I may have said that, but wrote 608. So 608 that's equals 258 feet taller than. That means 258 more than. And more than means add, addition. So that's a plus 258. Twice Laurie's height, or twice the height of the tallest building in Laurie's hometown. And x is representing the height of the tallest building, so twice the height would be 2x. Okay, and now we need to maybe rearrange the order. Just because information comes in a certain order in English doesn't mean it's going to come in the same order when we translate to mathematical notation. So we could say 608 equals, well, let's put the plus. We need to, if we're adding something, if we're adding 258, we need to add it to something. So we could put the 2x first and add the 258. So we have the height of Anne's building, the 608, is 258 more than, plus 258, twice the height of the tallest building in Laurie's hometown. That's the 2x. Okay, so here we have our equation. And again, as is the case of any word problem, unless you're given an equation in the word problem, you're taking a statement in English, you're translating it to a statement using mathematical notation, and just setting up the problem, often setting up the problem, accounts for 90% of the work. Now, once you have this, we could solve this in 2 steps, 2 relatively quick steps. And that I'll cover in the next videos where we actually solve the equations, but I think it's important to talk about how to set problems up before we talk about how to solve those problems and get the final answer. So after this video, from here on out, anytime there's a word problem, and there'll be many, many of them, in my solution videos, I'll talk about the setup, and I won't stop there. I'll set it up, set up the equation, and continue on to solve for the final answer. Okay, that's it for this video. I'm going to solve the next 4 problems in my next video, which, if you have time, hopefully you do, you will watch immediately following this one. Okay, hope this was helpful.